All right, let's dive right into this explainer and really build a solid, ground up understanding of health information systems. If you've ever interacted with modern healthcare, whether you're a clinician typing in patient data or maybe just a patient checking your test results on your phone, you've touched a health information system, or an HIS as we call it. But honestly, that surface level, it's just the tip of the iceberg. What we're actually dealing with is this massive, invisible structure that you really only notice when it stops working. So today, we're popping the hood. We're going to focus strictly on the foundational concepts, the core tech, and the rigorous frameworks that actually make digital healthcare a reality. Here is our roadmap for today. We've got a clear six-part agenda. First up, the plug-and-play myth, then the HIS conceptual model, followed by core technologies and systems. After that, we'll look at what happens when health systems fail, check out the guardrails of standards and governance, and finally, peek into the future of health tech. So, let's kick things off with Section 1, the plug-and-play myth. We live in this incredible world of smart devices and instant downloads, right? And that's kind of created this illusion when it comes to enterprise healthcare systems. Swiping an iPad or logging into a patient portal feels like magic. But here's the truth. Access devices and networks don't actually create data on their own. They rely entirely on a painstakingly built technical foundation to capture that data. It's actually created in properly implemented source systems that support the actual workflows of healthcare providers. It is a massive, complex construction project, definitely not a simple app download. Moving right along to Section 2, the HIS conceptual model. To truly get this, we need to look at the structural blueprint of health tech. Think of this architecture like a giant puzzle, or maybe a series of concentric circles building outward. Right at the absolute center, the core, is the HIS technology and infrastructure. As you move out, you find systems and management, and then the people and processes actually using them. Only after those layers are rock solid can you move into data and informatics, up to analytics and AI, and finally, the outermost layer of global policy and research. You absolutely cannot slap the roof of AI onto a healthcare system without first pouring that solid central foundation of basic infrastructure. It just won't hold up. Which brings us to Section 3, core technologies and systems. Let's get our hands dirty and define exactly what those foundational building blocks are. Block number 1 is hardware. This is literally the physical stuff, the machines and devices that let end users interact with the system. We're talking about everything from those massive humming servers sitting in a hospital's temperature-controlled basement to the tablets nurses carry on the floor, the barcode scanners down in the pharmacy, and the regular old PCs at the registration desk. It's the physical backbone that holds the whole operation up. Next up, block number 2, software. If hardware is the body, software is the brain. These are the active programs and applications that actually execute the specific clinical and administrative tasks. They're built using super complex programming languages just to process all this data. Ultimately, software is what the knowledge workers, your doctors, your nurses, the administrators, are actually staring at and interacting with all day to get their jobs done. And the third block? That's infrastructure. Think of this as the digital superhighway. It's the vital network that safely carries all that data traffic back and forth between the hardware and the software. It encompasses the physical fiber optic cables running behind the hospital walls, the routers and switches directing traffic, and of course, the bandwidth connectivity. That bandwidth is absolutely crucial. It ensures that when a doctor pulls up a massive high-resolution MRI, it loads instantly and securely without crashing the entire hospital network. Now, running on top of all that infrastructure are two heavy hitters, two main types of massive software systems. First, we have electronic health records, or EHR systems. These are strictly for clinical patient care. This covers patient registration, clinical documentation, lab results, the pharmacy, the whole 9 yards for the patient. On the flip side, we have enterprise resource planning, or ERP systems. These keep the business side running because, let's remember, a hospital is a massive business. The ERP handles the general ledger, supply chain management, human resources, and payroll. Both are absolutely critical. They just serve entirely different purposes within the organization. So, what happens when it all goes wrong? That's Section 4, when health systems fail. Because let's be real, not every IT rollout is a massive success. A huge point of failure is a lack of interoperability. Imagine a patient breaks their leg while skiing in Utah and gets an X-ray, but their physical therapist back home in New Jersey can't even access that digital file because their systems literally don't speak the same language. The technology has completely failed. It's a stark reminder that without common communication protocols and data standards, multi-million-dollar tech is basically useless. It's honestly no better than just mailing a paper chart across the country. So what separates the winners from the losers here? Well, foundational success absolutely requires expert input. The best systems are designed hand in hand with subject matter experts, the actual clinicians and admins living the daily workflow. On the other hand, failures almost always stem from ignoring the people who actually have to use the system. If you skip that expert input, you usually end up with inadequate funding, terrible communication, zero end-user training, and a system that's just destined to collapse. If you ignore the fundamentals, the tech will fail, no matter how fancy the software is. To prevent those disasters, we look to Section 5, Guardrails, Standards, and Governance. Enter HIS Governance. Governance provides those much-needed guardrails. It's essentially the leadership structure that dictates who makes the decisions, ensuring that IT projects actually serve the healthcare organization's bigger goals. It's all about accountability. Good governance ensures tech investments are evaluated, properly funded, and that the IT department is running efficiently enough to actually support the whole organization safely. And organizations don't just wing this, they adopt formal, battle-tested frameworks. Take ITIL, for instance. It's super common in healthcare. It sets up standardized processes, like how to run a proper service desk, and establishes service-level agreements to make sure end users are actually happy. Other frameworks like COBIT and the ISO standards do similar things. Let me tell you, trying to deploy complex healthcare applications without these formal governance frameworks is pretty much a guaranteed recipe for total organizational chaos. And then, of course, there's the big one, external governance through federal regulations, most notably HIPAA. HIPAA forces a strict step-by-step approach to securing digital health data. And it's way more than just keeping a secret between a doctor and a patient. It legally requires standardizing how data is exchanged electronically, aggressively protecting privacy, locking down electronic protected health information against hackers, and, this is huge, requiring organizations to publicly sound the alarm if a data breach does happen. These guardrails, they are absolutely non-negotiable for any health tech architecture. Finally, let's wrap up with Section 6, the future of health tech. Let's see what's being built on top of this foundation. We are looking at some wild advancements, like deep learning. This leverages the massive mountains of data collected by these core systems. Deep learning literally uses brain simulation, creating artificial neural networks with multiple layers that actually learn and get smarter the more data you feed them. And the crazy part? They do this without human engineers designing every single step. This is creating incredibly powerful AI aids that offer clinical decision support we couldn't even imagine a decade ago. And we can't forget about blockchain. This technology offers a totally new way to manage the underlying structure. As a distributed, immutable ledger, blockchain has the potential to completely revolutionize how we secure healthcare transactions, lock down patient records, and track massive medical supply chains, guaranteeing data integrity across huge networks. Which brings us to the end of this explainer and leaves us with a pretty fascinating question to chew on. As the roof of our healthcare technology gets incredibly advanced with things like AI and distributed ledgers, how is that going to force us to upgrade and adapt the foundational building blocks? The hardware, the infrastructure, those basic data architectures that we're relying on today. Because technology never stops evolving, and neither can the foundations holding it all up. Thanks so much for joining me as we build up our understanding of health information systems. Keep questioning, keep learning, and I'll catch you in the next explainer.